Hello, I'm Nithilan, and in this video, I'm going to talk about the code and implementation of a transformer architecture from scratch, which is built using pytorch. Okay, a transformer is a sequence to sequence architecture that relies entirely on attention mechanism instead of recurrence or convolution. It processes input sequence in parallel, making training faster and more scalable. By using self attention, it captures long range dependencies effectively, which makes it highly suitable for machine translation. So, we'll start to look upon the modules which are used to build a transformer architecture. So firstly, with input embeddings. Okay. This layer converts each input token into D model. So the embeddings are scaled by root of D model to maintain stable variance during training. So the next one is positional encoding. Since transformer have no recurrence, unlike RNN in some sort of convolutions like that, positional encodings add word order information. It uses sine and cosine functions so that the model can learn relative positions of tokens. And thirdly, layer normalization. This layer normalizes activations across feature for each token. It stabilizes training and speeds up convergence by reducing internal covariance shift. Feed forward network. A two-layer fully connected network applied independently to each token. It increases model capacity by introducing nonlinearity using ReLU activation. Multi-head attention. This layer allows each word to attend to all other words in a sentence. Multiple heads help the model capture different semantic relationships in parallel. Residual connection. Residual connections add the input directly to the output of a sublayer. This helps prevent vanishing gradients and enable deeper networks. Encoder block. Each encoder block contains self attention followed by a feed forward network. Residual connections and normalization are applied after each sublayer. Decoder block. The decoder block has masked self attention, cross attention, and feed forward layers. Masked attention ensures predictions depend only on previous target tokens. Projection layer. This layer maps decoder outputs to vocabulary size. Transformer. This is the final transformer which embeds all the modules which are previously spoken about. So, okay. The transformer combines encoder, decoder, embeddings, and projection layers. It separates encoding and decoding and prediction for modular design. Now we'll be looking at the training sector of the transformer architecture. So, firstly, at get all sentences. It extracts sentences from the dataset of a given language used to train tokens from raw data text. Get or build transformer creates a word level tokenizer if it doesn't exist. Ensures consistent vocabulary usage across turning runs. Get DSS dataset where we'll be extracting dataset from other source and using the transformer we'll be using configuration and we'll be using configuration values and this helps to keep the model creation separate for flexibility. So after that, We train the model. We train the model using the train data loader, validator loader, tokenize the source and target. We use Atom optimizer and cross entropy loss for loss function. After that, we save every box which are downloaded from here